this is our question. A boat is traveling due north at 27 mph and a current is flowing at a varying of south 60 degrees at 8 mph. And the question wants to find the actual speed and the direction of the boat. So from the first sentence, we know that the boat is traveling due north at 27 mph. So we give the boat the symbol B, okay, and it's 27 mph. And a current is flowing, so the current 60 degrees, so what is our 60 degree? So since we don't know the x coordinate or y coordinate for both vector, so we should write both vector in terms of their magnitude and also direction. So we get 27 is magnitude and cosine 90 degree and sine 90 degree, because here is our 90 degree. And for vector C, x is magnitude and cos 210 degree, because from here to here is 270 degree. So 270 degree minus 60 degree, we get 210 degree. The question asks to find the actual speed. So actual speed actually is equal to vector B plus vector C. So after we put the value into the calculator, we get negative 6.93 and 23. And we find its magnitude and we get 24.02. So the next is find the direction of the boat. So the direction of the boat, we can find it through the tangent theta equal to 23 over negative 6.93 and we get negative 73 degree. Okay, here negative, okay, we don't need to worry because negative 73 indicates the angle actually start from here to here. Okay, so its bearing actually is north 70 degree west, which is here. And the actual speed is 24.02 mph. Okay, that's all. Thank you.
Hi, have you wondered why when you are swimming in the water, you felt the water current pushes you and change your direction as well? So in this question, it is related to the situation that I have stated before. So the question asks about a swimmer swims across river towards north with constant velocity is 1.8 milli per second. The current of constant velocity is 0.8 milli per second flowing towards it. Determine the resultant velocity of the swimmer. So before we answer this question, we have to recognize the information given to us, which is velocity of water is 0.8 milli per second and velocity of swimmer is 1.8 milli per second. But how can we have two velocity of swimmer since the question asks about the resultant velocity of the swimmer? So it is actually 1.8 milli per second stand for velocity swimmer relative to the water, because 1.8 milli per second is affected by the current of water. So we assume that 1.8 milli per second is velocity swimmer relative to the water. So in order to find the resultant velocity, we use this formula, which is resultant velocity equals to square root velocity of water square plus velocity swimmer relative to the water. Then we substitute the value to the equation and we get 1.97 milli per second. So in conclusion, when the swimmer is trying to approach to the surface of the water, this is the straight line is actually the direction that we plan, that the swimmer plan. But the truth is, it is actually this is the true direction of the swimmer when the swimmer approach to the surface of water. So this is one of the application in the vector. That's it for me. Thank you.
We move on to the next question, which is an athlete runs 10 km north along a straight road, then turns 5 km east along another straight road. What is his final displacement and direction? So we're going to use the direction here, which is north, east, south, and west. So from the information given in the question, we can determine here the athlete runs 10 km upwards, which is to the north, and then 5 km to the right, which is east. And then we get this triangle. So from this triangle, we're going to find his final displacement using formula of magnitude, which is C equal to square root A square plus B square. So from here, just substitute the value, which is C equal to 10 square plus 5 square, and then we square root the value. Where we get this, which is here and here. Then just press the calculator, we get 11.18 kilometer. That is for his final displacement. And then we're going to find the direction. So for the direction, we can use either sine, cos, or tangent. So from the information given, we get the angle here, and then from the angle here, we have the opposite and the adjacent. Therefore, we use tangent theta equal to opposite over adjacent. So tangent theta, we substitute the opposite is 5 km and the adjacent is 10 km. So theta equal to tangent inverse 5 over 10, and we just press the calculator, we get 26.57. So for the conclusion, the final displacement of the athlete is 11.18 km, and the theta for the athlete is 26.57 degree. So the athlete runs 26.57 degree between north and east. Thank you.
So the last question is, a ship leaves port on a bearing of 28 degrees and travels 7.5 km. The ship then turns east and travels 4.1 km. How far is the ship from port and what is its direction? So from the information given, we can draw the diagram. So the ship has a bearing of 28 degrees and travels 7.5 km upwards. Then the ship turns east, which is 4.1 km, and then we have the resultant vector. So to find the resultant vector, we have to use this formula, which is magnitude of vector squared equals to a squared plus b squared minus 2ab cos c. So we have to find cos c. To find cos c, we have to use the concept of interior angles. First, we have to calculate this angle first. Since we know this angle is 90 degrees, so we have to minus 90 degrees and 38 degrees, and we get here is 62 degrees. And since here and here is the interior angles, so we have to minus 180 degrees minus 62 degrees, and then we get 118 degrees. And this is the C. And then we substitute in the values, which is A is 7.5, B is 4.1, and cos C is cos 180. And then we calculate and we get R, magnitude of R is 10.1 km. Next, we have to find the direction, which is we have to use this formula. Sin C over C equals to sin B over B. Since we get C is 118, so we just substitute in sin 118 over 10.1 equals to sin theta, which is we have to find, over with 4.1. So sin theta, we calculate, we get 21 degrees.